So this is a tutorial to show you how to use the EPLAN platform when it comes to harnesses. So let's start. First, we have to create the schematics. The schematics for something like a snowmobile like this, right? Can have different looks. Here, for instance, we have a typical left to right look where we have the fuse, and let's see if we concentrate here on something like the cutoff switch and high beam, low beam type of switch that is actually on the handle. So every area of the machine was identified, like here ST for steering, STL for left, STR for right on the steering, and every object inside these structure boxes are automatically assigned or reassigned to that particular physical location. So here we have a wire. Each wire, of course, has a part number, so we know what the size of the wire is, what the gauge of the wire is, the color of the wire, and then we have connectors. These connectors, like every other connector, has, of course, a part number. Here we can see we have actually a plug, and you have the counterpart, which is basically on the other side here, the PL1, which is the female portion of that connector. So of course they have mating parts, and this is all described in a library. So we have these two connectors here and the different details about each of these connectors in terms of mating parts, what kind of cavity pins or wire pins. Everything is actually defined in this library. So going back to EPLAN, we also have an interesting option drawing the schematics themselves, because in EPLAN, every time you place an object, you can see that the wires are actually smart connected wires. These objects here, if I unplug the smart connect, there is a auto connect that appears. These have the possibility in EPLAN already at this point in the electrical portion. We already have a device tag list, a wire list that can actually be generated in form of a report, of course. And these are the two primary elements that are interesting when we go to the harness world, because they have to position specifically these connectors and specifically also these wires. But before I continue going there, I'm going to show you an interesting feature called the project option. Opening this navigator here, which is the options navigator, I can actually predefine certain options that have some inputs and outputs, and if you uncheck them, some sections of the schematics may actually disappear or be turned off. And this is true for multiple different pages or entire pages all in all. So if I take, let's say, a snowmobile with no options at all, the number of schematics I have are, of course, a little bit less. It's a little bit easier for our exercise here to understand how it works. Let's concentrate on this particular push button that is on the steering portion left and on the steering, and let's move on to the harness side of things once the design has been done. Of course, all the features of the electrical P8 do apply here, and now we'll jump over to the harness section. So in the harness section, the first thing we actually do is to import simply the 3D model, so to say. So we are importing here the 3D model from tools like CATIA or any other 3D system, and then we are placing these individual connectors. So if we concentrate, let's say, on the STL push button that we were looking at, and we're trying to find it on this particular one here, we can see it's tagged up here, and it's right sticking into this portion. So of course this model is not a perfect model coming from the manufacturer. It's one that we recreated to actually be able to position these connectors. So that's the job number one we have to do. You want to move them, all kinds of different 3D objects or movement possibilities you have. You can rotate, etc. It's quite interesting actually how this 3D model here works. Now the second step we have to do is to define different wireways. In this case here, we can look at a wireway bundles that were positioned for the harness that goes to the steering left and right. The step behind this is to actually add the wires. So now the wire information knows that we go from one connector, as you can see, straight up to another connector. But of course, this is not how the routing will be routed. So the final step is actually to run the automatic routing, and this creates then harnesses, complete harnesses like this. Here we're looking at a harness with a specific bundle section. And if you want to see the other harness that we also created, we just have to turn it on. We can show it here. So here we have the other portion. And this, of course, is on this assembly that I can also show. So on the whole snowmobile here, right? So you can see that it's all positioned in place there. And if you have some of these bundle sections you want to move around, you can easily just move them around, reposition a little bit, recurve it. And by doing so, you are actually changing the shape of the harness itself, and indeed also changing the length of each individual wire that is inside. Another thing that we can see here, let me just take off this hood here. We can see when we get closer to areas like these where we have restraints because it's rotated a little bit too strong. So you can actually work on optimizing the bending so that, whoop, this is better. As you see, we actually eliminated the red portion of it. So here we are a little bit too squeezed. So we have to move, of course, our control around a little bit so that we don't have that much. Of course, we can't go inside, but we have to see where we can actually move it around the components that we see so we don't have these areas anymore. But I'm going to come back to this and fine-tune it, because the most important part is that once you actually have this 3D model, EPLAN harness is capable of creating a nail board. Now, nail boards are actually have a specific feature. They flatten out what is done on the 3D to actually put it on a nail board. And then, well, it comes with some documentation information, such as, you know, like a title block you can place. You can insert automatically some bill of material. That's basically just a table that you can spin on here. You can add a wire list, a detailed wire list. In here, you can see that we even have like individual wire list for what goes in this bundle or in this bundle or in this bundle. These individual tables, these are all updated automatically. So of course you will find wires here, up here, and here that are the same, because at one point in time not all wires go through all bundles, and some of them do go through the different bundles. And these tables are immediately and updated automatically. So if you do change something on the 3D aspect, the length here is always calculated 1-to-1. It's flattened out. And of course, if you need to have place like a more complex nail board, like this one here, where the wire is actually longer than what is allowed here, you can rotate and get around like this, and actually control these individual points by just simply rotating them around like this. Now, that was one I did not want. Let me just undo this, edit here. Let's just undo the last one. And what you can now do is, of course, put some more details. So one of the details that we like to put on there is to put a so-called here a connector table, right? So we have for each of these items, I'm just looking and giving you an idea of all the different items we have here, so you can place them individually, right? And you can place them through here. And what I want is, of course, a small connector table that basically will tell you here what is actually on this connector. So I can go on and on. This one here doesn't have it, so I just mark it up and I say insert please a connector table, and you just place it wherever you want. Now this connector table, of course, is nothing else than here the connector table, and you can just choose whichever you want and place it wherever you want, right? So the idea is simply by putting more detail. So if you want to put this one here, just go ahead, place it right there where we have some room. Let's zoom in just to show you a little bit better how this works. So this one here, I want to place it also, let's say here. There we go. We move on to the next one here. We pick this connector here, perfect. Where do we have some room here? No. Why don't we put it up there, right? Next one, etc. You can see it's very easy. If you want to have a wireless, a general wireless, you do the same thing. Insert a wireless. There we go. That's the whole global wireless for the whole thing. You want a bill of material. In this case, I think that a bill of material will fit, but most likely, well, it fits here. It could have fitted up here, and it's always updated. So once you actually have your frame, you can always come back and fine tune it. You can put some dimensionings, although the idea behind this is to actually place the strategic nails, knowing exactly where you want these objects to be place, right? So if you have a control point, let's say this is your control point, and you want to add a nail for this control point, the portion that is interesting is that you will always, based on these control points, if they move on the 3D, the nail will move with it. So that's the nice portion of it. You can of course leave it up there, and the guys will put their nails by themselves. These are just tricks and tips that you want on top of it. You can, on the 3D model, now decide that you want to change, let's say, some of the surfaces. You can assign different surfaces, protection surfaces. We call them here wrap tapes or looms that you can place for each of these. So you just have to pick which one you want, and you just assign it to a specific one. The color, of course, changes. That's all controllable. And once this is changed, then of course on the nail board you'll see the reaction. This is a very nice way of handling your harnesses. And at the end of the day, if you wish, you can actually take this drawing and export it as a 3D model, give it back to your mechanical guys, and they will actually see where your bundles go through, if they have to put some holes in certain walls or whatever. And that's primarily the exchange we have. So you let the mechanical guys work on their 3D model, you take it over, and you finalize it in EPLAN harness.